I got two intersecting lines that form four angles. I kind of went over this in the homework already, but just to make sure we're set. We got a bunch of different types of angles, but I'm looking at two specifically up here. Leo, what do I call 3 and 1? They're vertical. And what do I know about, what do I call 2 and 4? Vertical angles. If two angles are vertical, they are automatically, Leo again, congruent. Yep, so everyone's clear. 1 congruent to 3, and separately 2 is congruent to 4 because they are vertical. And we're going to use that in a proof now. Vertical angles are, you do not need to tell me they're vertical. You can go right to saying that they are congruent. All right, so let's use it in a couple proofs. Get your statements, reasons down here. Here's one of those if-then ones. Remember, I mentioned yesterday, whatever is with the if, that's my given. Whatever is with the then, that's my proof statement. And that's my proof statement. So set up your statements and reasons, and then we'll start marking the diagram. I don't care how you're writing in the givens, whether you write an arrow, whatever you write, but on Tuesday's test, you write out the whole thing. Okay, on Tuesday's test, we write out every given. I don't care what you do now, though. Put an arc, make sure, do we have arc marks at 3 and 2? Arc marks at 3 and 2, because those are given as congruent. And now I need your help getting 3 and 1 now congruent. 3 and 1. Okay, a couple things before we actually finish this proof. First thing, everyone see how I specifically numbered 3 of them up there? 1, 2, and 3. Here's why. A little teacher secret. I want you to focus on them only. All right. I really don't care about that one, and that one. There's a reason why I specifically chose to label those angles 1, 2, and 3. I want your focus on those. Okay. So if anytime I've labeled an angle and not other angles, there's a reason why. Just focus on the ones I've numbered. Second thing, I haven't gone over this yet. I put this in the givens right here, that EF intersects AB and DC, and I know people just write it in, and then you're like, who cares? I get it. I'd say the same thing. Who cares? Well, we care now. Here's another secret. If any time in the givens they write those are lines or they intersect, you know what they're telling you? Look for vertical angles or linear pairs. So anytime they're telling you in the givens, hey, this is a line, it's worth it because they're telling you either you're going to use linear pairs or supplementary or probably vertical angles. All right, so watch out for that. I know you just write it in and you probably disregard it. And this is probably what we're really looking at, 3 congruent to 2, but it matters. All right, so there's a couple teacher secrets there for you. How am I going to get to 3 and 1 now? Can you look at the diagram? Are there any other angles you know a relationship between up here? Because we're not going to be able to get 3 and 1 in step 2. All right, take a look up here. Remember, look at the numbered angles only. Look at the numbered angles only. Is there anything other than 2 being congruent to 3 because it's given? Anything else you see between 1, 2, and 3 that might help me? Amelia? What type of angles are they? What are they? Why? Because they're? What do we call them if they're opposite? Begins with a V, ends in vertical. Vertical angles. Everybody good? Know our vocab. Vertical angles. Good? So, yep, that's going to be step number 2. Angle 1 congruent to angle 2. And here's, it's not even a new fact. We've known this all along. Vertical angles are congruent. And yes, I will take off if you write definition of vertical. That's not the definition that they're congruent. vertical angles are congruent, and that's our final fact. I'm not done though. I'm not done. You guys see the proof statement. Get me 3 congruent to 1. Well, look what we have congruent already. We have 3 congruent to 2 and 1 congruent to 2. I think I see something we talked about the very first day when I started the proofs with you. Warren, what do you see? Reflexive is 3 equals 3. 1 equals 1. Reflexive is something equal to his exact self. 3 equals 2, 1 equals 2. What can I get out of those, Jane?
Substitution.
To say what? 3 equals?
2. Oh, 1, sorry.
1, right? Hey, everyone. I see repetition, repetition, repetition. Anywhere I see a 2, I substitute in 1. And there it is. Substitution. Repetition, repetition. I can use substitution. Last questions on this one, because they are going to get significant, not significant, they're going to get tougher. Okay, they're getting tougher. All right, next up. Another if-then one. Oh, lines intersect. I must be looking for something then. Lines intersect. Wonder why they're telling me that. Little secret. Gonna need some studs for this, just letting everyone know. Studs only on this. You got arc marks on your diagram? X and Y. And our goal is to try to get M and N. First thing, get out of your mind, M and N are not vertical. Okay, this is not a 2-step proof. They're not vertical. Right? They're not formed by 2 intersecting lines. Okay, so M and N, even though they look across from each other, here you go. Here's M. Here's N. I don't think those are 2 intersecting lines, right? Okay, so that's why they're not vertical. But we do have another pair of intersecting lines up here that I will highlight for you. AEB and CED. I got those 2 vertical. Those 2 intersecting lines. I wonder why they told us they were intersecting. All right, take a peek at it. Take a peek at it if you want to. I'll give you a couple minutes here. How else? How can I use those intersecting lines to get to M and N? Because they're not vertical. If you want to discuss it with people around you, that's fine too. I know this class is not a big talking class, God forbid. Got to talk to people around you. If you want to do that, go ahead. I really don't want to give this one away here. How we're going to get M and N. And remember, we only have so many things over there we could use. All right, we're not going to start adding our own reasons in, that's for sure. Put those intersecting lines back up there for you. Anything there. I'm going to try to get M and N equal. Maybe. Okay, hold on. There's a reason why they said the lines were intersecting. They wanted you to look for something. All right, you ready, Sloan? And if you're wrong, I give a lot of respect to you because you got guts.
Like On the DC, is it supplementary with like
What DC?
DEC?
DE, the straight
like the
line?
and the it's like supplementary. I don't like know the angles because there's so many letters.
Well, you can name it with 3 letters.
DMF.
DEF
Yeah.
or angle M.
Angle M.
Yep.
X. And AXC. Or I don't know. AC.
So you're going the supplementary route here. Here's, like, if I take this straight line here, DEC, and I got angle Y down here, I would need this whole angle, though. That's the problem, and that is more than I have for angle N. You're in the right area, I'll tell you that. Okay, you are in the right area. But you see how it's more than angle N? That would make it supplementary?
Yeah.
Okay. What's up, Evan?
I think angle DEA and BEC.
Stop. Okay, let me just mark the ones Evelyn just told me here. Ready, everyone? She said DEA. Everyone see this big dog right there? DEA. And what's the other one you mentioned? BEC. Everyone see this big dog right there? What type of angles did I just mark? What type of angles did I just mark? Vertical. And what do you know about them? They're congruent. I don't know if that, hopefully that helps somebody up now. Helps a lot of you to see. All right, if those are congruent and X and Y are congruent, how I'm going to get to M and N. And I'll stop right there. I'm going to put Evelyn's vertical angles up here. DEA congruent to BEC. That's why I gave you the intersecting lines to see those vertical angles. That's why I gave them to you. All right, I'm hoping now I have at least 90% of you in this class that can see what do I do now to get to M and N. You have the vertical angles congruent and you have X and Y. I can do something with those to get to M and N. And hopefully now more people are jumping on board. Lauren?
Angle.
What do you want me to do with the angles?
Subtract.
Darn right. I'm going to subtract them. Everyone, yes? I'm going to subtract the vertical angles from X and Y. I'm going to get smaller there. Yep. So I'm going to do angle. Let's see, Warren, you want to help me out here? If I take angle DEA, that vertical angle, what do I need to subtract from it?
Angle X.
Good job. Set that equal to the other vertical angle, BEC. And what do you want me to subtract from that one, Warren?
Angle Y.
Angle Y. Yes. There it is. Need 2 pair. Hey, I need 2 pair, right? Oh, I already got it. The given one and the vertical angles. Subtraction, and guys, how do we always end a subtraction or an addition?
Substitution.
Yeah, it's not changing. I promise you. Angle M congruent to angle N. Woo! Second pair was vertical angles. Second pair was vertical. All right, good. Any of that? A little tougher, huh? But hey, I'm hoping you guys start noticing the lines intersecting, make vertical angles or supplementary angles. And one more. One more. Wow, boy! 6 different angles labeled. This guy, 6 different angles. All right, let's do this. Telling me they're straight angles, okay, and they intersect up there, good. A lot of givens, huh? 1 congruent to 2 and 2 congruent to 3. All right, let's talk. We got to get somehow 4 and 8 equal. Or sorry, 4 and 6. They're not vertical, but I need to get them congruent. Can we start with the two givens? If 1's congruent to 2 and 2 is congruent to 3. Can we stop right there? Any other angles we know are congruent, and based on what? Another pair of angles that are congruent. Charlotte? 1 and 3 have to be equal because you saw a repetition and you thought, what fact? Why 1 congruent to 3? What is it? 1's congruent to 2 and 2's also congruent to 3. Anywhere I see a 2, I can blank substitution. So that's what we use, substitution. So we got 1 congruent to 3 as well. All right, I'm going to help you guys out. Well, give me what are the two angles in the proof statement that I need to have congruent? 4 and 6. So how about something about one of those angles? All right, why am I going to tell you something about 5? It's not even part of the problem. So right now, I'm going to call on somebody. I need somebody to tell me a true fact about either 4 or 6, because those are in the proof statement. And I need something about either angles 4 or 6 up here. Give me something that is true, and there's a whole bunch of things you could tell me. But stick with what's in the proof statement. Angle 4 or angle 6. Pick one and tell me something that's true about it in the diagram. Ariella. All right. So that makes them congruent. So 4 congruent to 1. Good, great job. And that's going to be vertical angles are congruent. 4 and 1. Good work. I would prefer you do not list every single vertical angle. Your mind's going to explode. So stop right here right now. Go back to step 2 and look at it with step 3. 1's congruent to 3. 4's congruent to 1. Now what two angles have to be congruent? Think about it. 1 and 3 are equal. 4 and 1 are equal. Now we're going to go to which two angles are equal. Based on those two right there. Here we go. Nope. Let's try that again. Sloan, you wanted it. 1 and 3, 4 and 1.
4 and 3.
4 and 3 are now equal. Yes. What'd you do to find that? Substitution again. Oh, we got a couple substitutions in this proof, huh? Again, we took angle 4, substituted it in for angle 1. All right, we got 4 cleared. What have we not spoken about yet? 6. How about a fact about 6? It's in the proof statement. Go back to the diagram. How about a fact about angle 6? Shoom, Taylor. 3 and 6 are vertical, so they're congruent. 6 is congruent to 3. Oh my good Lord. We got a 6-step proof coming up here. Look how quickly you've grown. 4 and 3 are congruent, so are 6 and 3. 4 and 3 are congruent, so are 6 and 3. Can you put those two together and tell me a new pair that must be congruent? 4 is equal to 3, so 6 is equal to 3. So which two now are equal to each other? Where are we going deep there, Jack? 4 and 6, and hey, look at that, what Jack got us. That's our proof statement. How do you know 4 and 6, Jack? Because of?
6 and 3.
Well, what are you doing to get to 4 and 6?
Substitution.
Yeah, substitution. Do not, hey, I'm warning everybody. We had what? Look, we had 2 pair of vertical angles. Don't put them in the same step. Your mind will explode. Keep them separate. Write it, use it with substitution. Write it, use it with substitution. All right, don't try to write all the vertical angles in one step. It'll be chaos. All right, I'm done. You guys are on your own. I'm really going real light today, huh? You only have 3? Woo! All right, go ahead. Probably could get this bad boy finished.
I can do it like Monday, 7:30.
Okay, that's fine. Just come on in.
Okay.
All right.